This video is about finding Maclaurin series of given functions. We know this is the formula for Maclaurin series. We are given f of x equals e to the 3x power. We want to get Maclaurin series up to 3 terms. So we set up this table. E to the 3x power. First, the derivative will be e to the 3x power times 3 using chain rule equals 3 e to the 3x power. Then derivative of this will be 3 times e to the 3x power times 3 equals 9 e to the 3x power. Nth derivative of f of 0, 1, 3, 9. We do know x to the nth power over n factorial will be 1 x squared over 2 factorial. Next one will be x third power over 3 factorial. 1 x squared over 2 factorial. This is x squared over 2. Then we will do multiplication. 1, 3x, 9 over 2x squared. The Maclaurin series of e to the 3x power equals 1 plus 3x plus 9 over 2x squared, and so on. Let's go to B. F of x equals 1 over 1 minus 2x to the third power. Change this into single power form. 1 minus 2x to the negative third power. Derivative of this function, negative 3 times 1 minus 2x to the negative fourth power, then times negative 2 equals 6, 1 minus 2x to the negative fourth power. For f double prime of x equals 6 times negative 4 times 1 minus 2x to the negative fifth power, then do the chain rule, negative 2. 48 times 1 minus 2x to the negative fifth power. 1, 6, 48 is 1x, x squared over 2. Do the multiplication. 1, 6x, 24x squared. Therefore, for f of x equals 1 over 1 minus 2x to the third power equals 1 plus 6x plus 24x squared, and so on. Let's go to C. Square root 1 minus 3x. We will change into single power form. 1 minus 3x to the 1/2 power. Then f prime of x is 1/2. 1 minus 3x to the 1/2 minus 1 is negative 1/2. Then chain rule times negative 3. Organize negative 3 over 2 times 1 minus 3x to the negative 1/2 power. For f double prime of x equals negative 3 over 2 times negative 1 over 2. 1 minus 3x to the negative 3 over second power times negative 3. Organize negative 9 over 4. 1 minus 3x to the negative 3 over second power. 1 negative 3 over 2. Negative 9 over 4. 1 x squared over 2 factorial is x squared over 2. So we get 1 negative 3 over 2x. Negative 9 over 8x squared. The Maclaurin series for square root 1 minus 3x is 1 minus 3 over 2x minus 9 over 8x squared, and so on. Find the Maclaurin series by given function. Guided practice 2. Using the Maclaurin series of e to the x power, find the Maclaurin series of the following function up to the first 4 terms. F of x equals e to the x to the third power. E to the x power equals 1 plus x squared over 2 factorial plus x to the third power 3 factorial. For e to the x to the third power, we will do the substitution, change every single x into x to the third power. So we have 1 plus x to the third power plus x to the third power squared over 2 factorial plus x to the third power, then to the third power of 3 factorial plus. So we have 1 plus x to the third power plus x to the 6th power over 2 plus x to the 9th power over 3 factorial is 6, and so on. Guided practice 3. Using the Maclaurin series of e to the x power and cosine x, find the Maclaurin series of the following functions up to x to the third power. We do know e to the x power, that equals 1 plus x squared over 2 plus x to the third power over 6. We stop x to the third power over 6 because we need a term up to x to the third power. Then times cosine x is 1 minus x squared over 2 plus x to the 4th power over 4 factorial. Since we only need x to the third power, so we don't have to write down this. Then we go to do the FOIL. While you do the FOIL, just remember, if your exponents of x greater than 3, we don't write that down. Equals 1 minus x squared over 2. Then we go to x. X times 1 is x. X times negative x squared over 2 is minus x to the third power over 2. Then we go to x squared over 2 times 1 minus x squared over 2 separately, plus x squared over 2. X squared over 2 times x squared over 2, the exponents of x is 4. So we skip this term. Let's go to x to the third power over 6, this term. Multiply by 1 is a positive x to the third power over 6. X to the third power over 6 times negative x squared over 2. The exponents greater than 3. So we skip. Then you need to simplify. 1 plus x, negative x squared over 2, positive x squared over 2 will be 0. Negative x to the third power over 3, and so on. So this will be the Maclaurin series for e to the x power times cosine x. We can also find Maclaurin series by binomial expansion. For example, find the binomial expansion of 1 over 1 minus 2x to the third power up to the first 4 terms. We got to use this formula. 1 plus b to the nth power equals 1 plus n taken 1 times b plus n taken 2 times b squared plus n taken 3 times b to the third power, and so on, equals 1 plus n times b plus n times n minus 1 over 2 factorial b squared plus n times n minus 1 times n minus 2 over 3 factorial b to the third power, and so on. So for 1 over 1 minus 2x to the third power, we can write down 1 minus 2x to the negative third power. This will be b. This is n, equals 1 plus negative 3 times negative 2x plus n times n minus 1 is negative 3 times negative 4 over 2 factorial negative 2x squared plus negative 3 times negative 4 times negative 5 over 3 factorial times negative 2x to the third power, and so on. Simplify 1 plus 6x, 24x squared. 3 factorial is 3 times 2 times 1. Then reduce 80x to the third power, and so on. Therefore, for f of x equals x over 1 minus 2x to the third power, we can write down x times 1 minus 2x to the negative third power equals x times 1 plus 6x plus 24x squared plus 80x to the third power, and so on. Do the distributive property equals x plus 6x squared plus 24x to the third power plus 80x to the fourth power, and so on.